Hello, this is Meena Mori, and the title of my talk is Use of Technology in Mathematics Education. Let us ask the question why. Today, there is a lot of discussion and awareness about new emerging technology and tools in teaching. So, we as teachers have to adapt with these new tools. Now, is it just for the sake of changing? The answer is no. We can augment our present teaching learning process with the help of these new technology tools. Now, how does a student benefit in this entire process? Research has proven that technology will help students understand the concepts and experience for themselves, which is sometimes difficult in the traditional classroom with chalk and board method. In many countries, there has been growing research to see how mathematical applications and modeling at undergraduate level has impacted their curriculum. Technology can help a teacher to play the role of a facilitator, which is a very crucial role of a teacher. It is observed that teaching obstructs the student imagination, and he gets used to believe that the content which is delivered by the teacher in the class is true without giving his own critical examination. Here, technology can be helpful where the student himself experiences the concepts and the steps. Research has already proven that the computer algebra systems and its tools that are available today can help to strike a balance between the skills and the understanding. In fact, it lightens the technical work and the monotonous steps involved in the paper pencil skill so that the student can focus on the concepts and the applications more than just the routine paper pencil work. This is another reference which tells us about how the education perspective is to integrate models and modeling in the teaching of mathematics, both as means for learning mathematics and as an important competency in its own right. Now, let me explain to you with two examples. One is the Lagrange's maxima and minima problem with the help of GeoGebra tool, and the other example of convergence and divergence of infinite series using the spreadsheet application. Let us take an example to find maxima and minima of the function f of xy, that is y minus x squared, subject to the condition g of xy equal to 2x squared plus y squared minus 2 equal to 0. Now I have already sketched the function f, that is the green curve, and the function g equal to 0, that is the red curve, which is the ellipse. Lagrange's theorem to find maxima and minima states that the maxima and minima of the function f occurs at those points on G where the gradient of f and G are parallel. So, before that, let me bring in the list of the level curves of f. So, we are basically trying to find all those curves or level curves of f where they intersect the red curve such that the gradients of f and g are parallel. That means if I plot the gradient of f and g function, which I have already done here, the red vector is the gradient to the g function, that is the ellipse, and the green vector is the gradient to the level curves of f. So as I'm moving this point j, you can see that how the vectors change their direction. So at this first point here a, you find that the gradient vectors are parallel. So this is one stationary point. Similarly, second one is at the point C, third at the point B, fourth at the point D. Now, let us concentrate on these four stationary or critical points that we have obtained. So let me remove the list again. Let us evaluate the value of the function f as the point of intersection G, which is the intersection of the f and the G curve changes. So if I move, this point of intersection changes. And now let us evaluate the value of the function f at the point G. In other words, let me enter the new function y equal to y of g minus x of g the whole square. So let us now look at the point of intersection. It exactly coincides now with the point A. And the orange curve settles at the value of root 2. That means at the point A, the function has the value root 2, which is going to be the maximum value. Let us now look at the other points. Notice as we are getting a single point of intersection, the value of the function f at these 2 points C and D settles to the value exactly equal to minus 1.5, which is seen from here as well as from the graph. Here exactly it settles at minus 1.5. That means this is the value at these 2 points. And now let us go for the last point. Here we notice that the function value is settling at minus root 2. So we notice that minus root 2 is little greater than minus 1.5. That means the maximum of f occurs at A and the minimum occurs at the 2 points C and D. Now let us look at the next problem of comparing the convergence and divergence of the sequence 1 by n, 1 by n square and their corresponding series. Now let us see how the spreadsheet application can help us understand the concept of convergence and divergence of sequence and its series. Let me select this graph. We observe that a blue box appears and this blue box continues down till n equal to 55. Now how did I get this graph? I have just selected this particular region and insert, then scatter and this. So that is what we get, which is already this graph. Let us observe what we have. 1 by n sequence, we all know, is a decreasing sequence. Then the sequence 1 by n square is a further rapidly decreasing sequence. That's clear from the graph. The summation 1 by n series, we observe, is increasing. That means here the student can understand and have a visual feeling of what happens to summation 1 by n as you add more and more terms. The sum is getting larger and larger. But on the contrary, for the summation 1 by n square series, the terms are getting settled somewhere close to 1.6269. And it does not seem to increase. In fact, it is bounded by 2. Thus, here the student gets a feeling of why the 1 by n series is divergent and the 1 by n square series is convergent. If I now choose this box and just drag this down to a very large number. That means I'm taking more and more terms in the series. So notice I have dragged this almost down to 399, very close to 400. This is the graph that I observe. So we notice that a similar trend observes when you take more and more terms. The graphs of both are almost having the same trend. Now let us take the next example of comparing the 1 by n series with the alternating 1 by n series. I have already entered 1 by n and its summation, the alternating series and its summation. And we observe that this light blue is the 1 by n sequence and the red curve above is its summation, which we have already seen is increasing. So it's a divergent series. But if you compare with its corresponding alternating counterpart, then the alternating 1 by n sequence, the green curve, is alternating and is settling very close to origin. And its corresponding summation is also settling down and is not increasing, but it is alternating and settling down at a value very close to minus 0.68827. So this is how we can make the students experience the convergence and divergence of infinite series. Now, let me conclude with the benefits of the technology tools for the two examples that we have discussed. A balanced and combined use of technology and the paper pencil skills can lead to a deeper understanding of the subject taught. The students are able to visualize the paper pencil solution obtained with the graphical solution. Through this experience, it is easy for the students to justify the steps followed in the paper pencil work. The geometrical visualizations that were observed using the tool GeoGebra will help the student to understand the logic and the philosophy of the Lagrange's multiplier method, and it will be visually convincing for the student, and hence he can recall the method very easily. Now, as the paper pencil steps are being worked out, an imagination goes on in the student mind. Now, the second example that we discussed of convergence and divergence of an infinite series with the help of spreadsheet application also will help the student to get a feel of the concept of limit and understand visually why the series converges or diverges. Finally, let me conclude with the free tools available for creating classroom videos. With the help of these tools, we can easily create and edit videos as screencast. They come with varied features in terms of operation, recording time, usage, and the final output. For this presentation, I have used the Screencast-O-Matic video recording tool. And these are the other window-based tools available: Cam Studio, Camtasia Studio, Jing, and Screencast-O-Matic. For the Linux-based, we have Record My Desktop, Kazaa, and OpenShot. Thank you.